All of you are welcoming warmly to Channel Planetique, and I am Anna Watson from Channel Planetique. Without any words, let's go for our video. The team behind the world's most advanced methane monitoring satellite, MethaneSat, are keen on metaphors about cleaning. About the size of a washing machine was how environmental scientist Stephen Wofsy described the orbiting object at a press conference ahead of its launch. Like a push broom was his phrase for its capacity to scan the surface of the Earth. The metaphors are apt. Methane is a particularly dirty greenhouse gas, driving about 30% of the heating the planet has experienced so far. It breaks down in the atmosphere in just 12 years, which is much sooner than the centuries taken by CO2, but it is also around 80 times more powerful over a 20-year time span. With 60% of global methane emissions coming from human activities, reductions are essential to reaching the world's climate change targets. Equally, if not addressed in a timely way, it could contribute to the passing of dangerous tipping points that lead to rapid and irreversible change around the globe. MethaneSat aims to help by providing an independent source of methane monitoring, with a primary focus on methane leaked from oil and gas fields, such as the recent months-long mega leak in Kazakhstan, which resulted in the release of 127,000 tons of the potent gas. By supplementing existing satellite data with even more precise measurements, MethaneSat hopes to provide a near-comprehensive view of global leaks from the only source of human-caused methane emissions. Agriculture is in fact the largest human source of methane emissions. According to the International Energy Agency, at almost 40%, energy is in second at around 37%, and waste in third. Within agriculture, flooded rice fields account for 8% of total human-linked emissions, but belches and manure from livestock are the biggest contributors, with cattle the biggest single offenders. In California, the nonprofit coalition Climate Trace found that one single cattle feedlot produced more methane than the state's biggest oil and gas fields. If we don't reduce emissions from the food system, we won't meet the 1.5C target, sums up Mario Herrero, a professor of sustainable food systems at Cornell University in New York, who oversaw the methane calculations used in the 2015 Paris Agreement on climate change. Animal numbers are increasing like crazy, thus methane is increasing. We have to reduce emissions from livestock. So why is farming's methane taking the back seat in terms of global attention? And what can be done to address this climate action blind spot? Monitoring methane. The rationale for focusing on oil and gas activities is that easy wins should be tackled first. If you're looking to have the biggest impact and make the biggest difference, it's reasonable to focus on oil and gas first, according to Mark Brownstein, a senior vice president at the Environmental Defense Fund, EDF. The environmental nonprofit funding MethaneSat and working in partnership with Google on the project. There's fewer actors involved than in agriculture, he told reporters. And there's also the resources there to solve it. Conversely, agriculture's methane output is more elusive. Aerial remote sensing measurements, such as those taken from aircraft or drones, can capture methane leaks, says Aaron DeWitt, principal analyst on remote sensing for the nonprofit Time. But these technologies can only be deployed in limited regions for limited amounts of time. Plus, even knowing where to direct remote sensors or satellites to look in the first place can be fraught. Adds Sam Schiller, chief executive of Carbon Yield, a firm that helps farmers adapt to climate change. In most parts of the world, public datasets of livestock facilities are hard to come by. New satellites. So can more precise satellites help? In the last 5 years, satellites have revolutionized our knowledge and understanding of methane emissions for the better, says Antoine Hal, chief analyst and co-founder at Kairos, an environmental intelligence company. Thanks to satellites, we can not only track the large emissions events known as super emitters with great accuracy, but also measure overall emissions at the basin or country level. Importantly, we can do so in a way that is completely independent and verifiable. According to Sarah McAuliffe-Fletcher, a biogeochemical scientist at National Institute of Water and Atmospheric Research in New Zealand, who is leading MethaneSat's agricultural research, that capacity will only increase in relation to agriculture too. The new satellite's ability to map methane at a precision of 2 ppb, parts per billion, means it will be the first satellite well-suited to measuring agricultural emissions, she says. That number might not mean a lot to your readers, but to me it is the same precision I could get from an instrument on the ground, which is extraordinary. In terms of methane from livestock, small groups of animals pose problems for satellite monitoring, as do farms in places where agriculture is not the primary emission source. I'm also not sure how well we will be able to do sheep, which have smaller emissions than cows, McCallum-Fletcher adds. On rice production, meanwhile, satellites cannot see through cloud and nearby wetlands can complicate the data. It is going to be more challenging, she says. Exempting agriculture. There are also limitations as a result of policy. A global methane pledge to reduce emissions by at least 30% by 2030, agreed at the COP26 climate summit in Glasgow, does not include an agriculture target. The agreement only talks about providing farmers with incentives and partnerships, rather focusing on all feasible reductions that the energy industry is tasked with, says Nusa Urbanik, chief executive at Changing Markets Foundation, a campaign organization. This reluctance to confront agriculture's emissions problem can be seen at a national level too. The US has a provision that exempts farmers from giving detailed emissions accounts. The EU recently removed a target for agricultural methane from its new 2040 climate goal. Why the reluctance? According to Howe, while fossil fuel companies are treated as certified carbon villains, there is a different aura around farming, where small family farms can sit alongside larger corporate operations. What would help clean up agricultural methane? There are some positive moves from industry to tackle the problem. A Dairy Methane Action Alliance has seen 6 of the world's largest dairy companies sign up to reducing their output, says Marcelo Mina, the former environment minister of Chile and now chief executive of the philanthropic Global Methane Hub. The meat sector, however, has not shown the same level of commitment and needs to do a lot more. The key to further progress, Herrero emphasizes, is less but better production of livestock. Methane from enteric fermentation, especially cow burps, is tricky to solve, but new breeding and feeding techniques could help. Read more about how New Zealand is reducing methane emissions from farming. Carbon count. The emissions from travel it took to report this story were 0 kilograms CO2. The digital emissions from this story are an estimated 1.2 grams to 3.6 grams CO2 per page view. Find out more about how we calculated this figure here. Experiments with red algae in dairy cows' feed suggest it may achieve reductions in methane, Herrero says. Meanwhile, in Japan, over 35% of food waste is recycled as pig feed, helping create a more circular food economy. But human diets may still be the ultimate blind spot holding up methane reduction. Of various measures that the EU could adopt to reach the UN Environment Programme's recommendation of a 40 to 45% reduction of global methane by 2030. A Changing Markets report found that 50% of consumers would need to eat less meat and dairy.